Hello and welcome to the next video. In this video, we will cover the regression problems in programming way. I mean, we will use models for the regression, linear regression problems. And before starting there, let's recap the previous discussion. As we know that there are two main types of the supervised machine learning. The first one is the classification, and another one is the regression. So the classification work with the classes, and the regression works with the continuous value. I mean the with the value where we can use the regression. So in that we there are two or three types are mostly we use in the regression. The first one is linear regression, and it's mean that only one independent variable and one dependent variable. And in the case of multilinear regression, more than one independent variable and one dependent variable. And in the case of logistic regression, one or more independent variable to predict the value from the target variable. So today I will cover the simple linear regression in the machine learning using the Python. So let's go to the collab. As we already using the collab, so I have just created a one notebook for the for my simple linear. I have just named it a simple linear regression. So what I had over here, I have imported a library NumPy. As we know that this is a open source library that support the multi-dimensional array. And then we are using the sklearn linear model. So that's why we are going to use the sklearn dot linear model. And as we know, we are covering the regression, so that's why we have used a linear model. In the case of classification, we will use a classification model. And we have imported the linear regression model. So in the case of logistic, this could be a different. And here what I have, as we know in our previous videos, we have imported the pandas library, the pd. And then we have to read the panda.read csv. And in the csv we are displaying the x value and then the y value. And then we are looping through, I mean using that csv throughout the code. But over here in the case of regression, we will use this we will use the I mean data set from through the csv. But now I have just to save the time, I have just created a one I mean two array, one for the x and one for the y. So as we know that in the case of classification, in the case of regression, we already have the value for the target variable. So this value we already know that these value will be, but we have to select that which value should be the appropriate value for that, right? So in the case of unsupervised learning, we do not have the target value, so we have to clusterize or classify all the stuff that to predict to predict the appropriate value. But in the case of supervised, we already knows that the target value and also the feature value, but we have to make sure that our model and all the things are working correctly. So but in the case of so the another uh, thing that I have to discuss over here, in the case of classification, we can check the accuracy of the model through the matrix dot accuracy. But in the case of regression, the accuracy is not a way to check that. uh, there is no way to check that the accuracy, but we can check the I mean the ability of our model with the three different approaches. One is mse mean square error and mser. And there are three actually errors method that we can use to that help us to check the performance of our model. Or actually we evaluate our model in that three different algorithm. But we can definitely use other I mean methods as well, but mostly people use these three, like we already have discussed this one, uh, where is that mean square error, like this one, loss or error, and where is that, this one, the error equation, in the case of error equation. So so let's go to the code. So before doing anything, I mean, in the case of writing the models, so there are almost 5 steps to write any model. So what are that steps are: first, we have to integrate, we have to import the packages as we already have imported, and then we have to use the data. I mean, we have to provide the data, like the data set. So in many cases we will use a csv file, or the website link. And then the third one is, we use a, uh, we use a model, like which model we are going to create, and to fit that model to the our, I mean, to fit the data to our model. So the fourth one is about the, I mean, the result, what actually the result is our model is returning, and what is the accuracy and all this stuff, right? And the fifth one is to predict the response, or to predict the our value. So these are the 5 steps we mostly use. So what I had over, that is, I have created a x and then the y, and I have used a reshape. Why I have used a reshape? Let me actually print the, as we know, we have a x in this way. So if I go here and print the x, we can see that we have a multi-dimensional array for the x, but over here we have only just one array. And in the case of y, we are using the same as it is array. Why we are using the reshape? Because we have to use a, I mean, use a more than one dimension, to be more precise, to have the column and many rows as a necessary. As we can see that we have one row, two row, three, four, five, six, right? And here what I have did, I have created a instance of the model. I use the name model and then the linear regression. So this model is also taking some parameter. The first one, of fit intercept, true, copy x, true, n jobs, and the positive false. So these are the extra parameter. If you guys want to use these parameters, so you can use that. So what actually the meaning of these parameters are: the first one is intercept. So the intercept, by default it is true. That decide whether to calculate the intercept when, I mean, the b our pointing 0, and to consider it equal to the 0. And in the case of normalization and so on, and the another one is a copy x. The copy x is also by default true, and that decide whether to copy or override the input variable or not. I mean, we have entering the value, and then we want to override or not. And the another one is a n job. That is actually the integer value, if that represent the number of jobs in a parallel computation. So this is when we are using a more than one resource, or like that. And another one is a positive. So that is also a parameter that help us to, uh, make a some kind of, uh, I mean, some kind of processing later stuff. Yeah, one, two, three, and four. Yeah, and then what I have did a model dot fit. I have added a x and y, and then let me run actually this model dot the and the fit. Now we can see that we have feed the model with the x value and the y value. And then here I'm using a coefficient rsq model dot score of xy. When I do print this, we can see that the coefficient of the our model is like this, 0.712. And then we want to intercept the model. So model dot intercept, when I click on over here, so it is showing the intercept 5.6.3, and then I'm just printing the coefficient, that is a 4.5, 0.54, and then we can use a x prediction model dot prediction, predict the response, and then I'm passing the y prediction because we have to use a prediction. And here if I want to plot the my results, so what actually the value will be, so I have imported the matplotlib.py plot as plt. This is a library to represent the data on the graph, and then the scatter yx, and then I have used a color, and then the plot x model and predict x has color blue, and I have used the title for my data set like this one, and the x value, I mean this value, and also the y value for this one, and then show. Now when I do click I mean run this code, we can see that our plot is showing, I mean the chart is graph is showing like this way. But this is just for a hard coded data that I have used a array over here, right? So in the case of csv, in the case of data set, so we mostly use a train and split to get the to get the, I mean x train and y train and x test and y test, because we want to predict the model in a different way. Like we want to check that is the model is what the model is predicting, I mean the what the model have in the case of testing, and what the model have returning or prediction the thing in the case of testing. So for that we are using the, in our previous video I already have discussed this one, sklearn model section, then train and split. So we are splitting 1 3 like the 70 to 30%, and click on this, and again model dot fit x train y train. When I click on this, and here I can use a print for prediction, that is a 3.5 point something, right? And then the thing over here, we can see that our chart, I mean our graph is showing like this way, starting from here x is 0, and so on. When it is going to the x-axis, also it is increasing the y as well. So here when we draw the line, we can see that all our points, all our I mean the value of x-axis and y-axis, it is showing away from the line. So if we make it the best fit line, like if we click over here and make a dot dot to fit this line, and then dot dot to fit this line, and dot dot to fit this line. So for that we can check that why it is not fitting. We can check that mean square error method. I mean this will gives us the I mean cost function, like we already have discussed over here in our, like I already have discussed the in a theoretical way. So this is the, like when we are when we draw the line, so like in our case when I draw the line in the code, in the coding way, I mean the in the python, so we have the same problem like we have over here, right? So it start from here. When we fit the line as per the best fit line, and we can see that here is the error, here is the error. But these points are, I mean these points are best fit, best truth ground. And in the case of this one, these values that are the on the top or on the bottom to this line, these are the error terms. That, so this is the same, and this is the same like here. But in while we were discussing the things, we have understand the MSE, mean square error, this work in with the formula like this one. And then we have discussed about like how to solve the formula in a way like MSE and y and y1 and mx plus bx and all that I have already discussed in a previous video. and but over here we are not using this formula. It will automatically, I mean this sklearn dot matrix dot, we are using a mean squared error r2. If I using a r2 square, and here we are using a mean square and then x test and y prediction. So it will gives us a mean square error. So this is the error that I mean this is the error term that our model is predicting. When we come to the when we go to the model again and we want to make a more predict that all this stuff, all these point will fit the line, and as we want. So we have to train our model in a different way. So there are different approaches to train the model, like L1 regularization, L2 regularization, and there are many more. But in our upcoming video, we will try to cover at least to make the model better, to predict the performance, and to overcome the error. And thank you for watching, and see you in next video.